Then I would say, let's start. So then welcome everyone to the fourth lecture covering today the topic of requirements elicitation. And with this topic, we are entering now the specification of the first content items as per recommendation by the only and wonderful AMDIRE reference model that we are using across the remainder of these course. Now, what have we done in the last lecture? To briefly recapitulate on the topics of the last lecture, we have discussed essentially three things. Number one being that available standards are insufficient for an explicit and integrated requirements engineering. Here we took two perspectives. Number one, we discussed the general notion of software process models, what they are, and that they largely ignore requirements engineering. If at all, they only briefly mention to document requirements, but they leave open the way of doing so. And we have taken the perspective on requirements engineering standards, which largely ignore the surrounding processes and focus, if at all, only on general outlines of documents to be considered. We have introduced the notion of artifact orientation as a great way to abstract from the way of working and to concentrate on what to be specified, but also as a way to give some indicators or blueprints on how to specify the contents following some refinement relationships over different levels of abstraction. And we have concluded by introducing the AMDIRE model. AMDIRE standing for Artifact Model for Domain Independent Requirements Engineering as a means to guide an explicit and integrated requirements engineering over different levels of abstraction. What you can see here on the right side is the pictogram of AMDIRE, and we will be using this very same more abstract and structural model as a backbone also for our contents to be discussed along the remaining lectures. Now, one of the core essences of AMDIRE is that it abstracts from the way of working, and we have discussed that this is a good thing. At the same time, there might be one question that always comes up, and this is, where do I start? Where do I even begin? And this is exactly what is in scope of today's lecture. We will be covering the general aspects of requirements elicitation and how to get started. And before doing so, we will be looking into the very first two content items of AMDIRE, being the stakeholder model, reflecting who is interested in the system, as well as goals and goal models reflecting why they are interested. We will be using both in the next two lectures to specify first functional requirements capturing the expected functional behavior of a software system, and non-functional requirements capturing non-functional quality-specific attributes of a software system. So just a small set of small postulates or notes. So we just assume that we are at the beginning of a project, of your project. This is of course obvious. One small note, reading the AMDIRE cheat sheet doesn't replace, of course, visiting the lectures, but the other way around also, visiting the lectures doesn't replace reading the AMDIRE cheat sheet. But please take your time. Nothing has to be done always immediately, but consider it along this course. And a final note from this lecture on, so in the past lectures, I should say, we have been focusing more on the very fundamentals, covering a big picture. Many things were a little bit more fuzzy and vague, but I wanted to increase your awareness and sensibility for certain aspects to be considered and principles to be considered in requirements engineering. From now on, we will be taking a more step-by-step view and looking step by step into the different content items that should be specified in the AMDIRE model. Think of the Advent calendar I mentioned in the last lecture. This is what we will be doing. We will be opening door by door and looking into the single content items and reflect together about the underlying concept model that dictate what to specify. And one consequence, the lectures from now on will also be in tendency shorter, sometimes even much, much shorter. The idea of the lectures from now on is to focus on the general what, so what to specify and why to do this. We will be using then the lab sessions to reflect together how to do this generally, and the project Q&A sessions, how to do this specifically for your project. Not everything we will be covering is important for your project, but at the same time, of course, this might serve as a great indicator. Now, let's directly start. We will be discussing three topics today. Number one, the stakeholders and stakeholder models, what they are, how to use them. Number two, goals and goal models. And number three, requirements, elicitation, and how to get started. Now, let's directly start with stakeholders and stakeholder models. So let's start with what is a stakeholder. Now, a stakeholder is a person or a group of persons, an interest group or an organization that has to a certain extent an interest in the system to be developed, or that otherwise may or may not take an influence on the system's development. Now, let's start with person or group of persons. Now, a person is an individual like Daniel Mendes who might have an interest in the ATM and might have some requirements on the ATM. Typically, I focus on the group of persons. In this case, it might be just the end users. So the collection of all possible users abstracted and captured as the end user who might have an interest in the software system. An interest group could be, for example, I don't know, a union representing the interests of the end users or the workers maybe behind the software system. It could be also something more straightforward like a community of practice. So these interest groups are typically great sources to elicit context information, to get a better understanding of the surrounding domain of the system. An organization is something more formal. An organization can be a regulatory body, a legislator. In the case of the ATM, it could be the central bank or the European Central Bank. Typically, organizations are a great source to elicit what we will get to know as constraints. So these are non-negotiable restrictions of the solution space, things that must be adhered to, not really requirements, but things that just must be followed, like specific demands on the way we develop, on the software process model chosen, or technologies that are imposed that have to be chosen regardless whether it makes sense for us or not. Now, let's directly start by discussing some examples. Let's consider again the ATM. What do you think could be exemplary stakeholders for an ATM? What do you think? Exactly. Very well done. You covered different views, what we call. I will explain views in a second. Typically, when we think about stakeholders, we think of the end users. But there are, as you said very well, many more. So different stakeholders have different interests that are captured by different views they have on a software system. And with those views come also different types of requirements. So end users are a great source to elicit typically functional requirements, because we use end users to understand how they intend to interact with the software system, how they intend to use such a software system. Customers I've added to this list to make clear that it's not the same actually. When we speak about customers, we typically mean those on the other side of a contract, the contracting body, customer as an abstraction of many different stakeholders, those who pay for the software system. Then we have legislators, certification bodies, unions, compliance managers, I don't know, standardization organizations, all those that serve as a great source for constraints, marketing and so on. Domain experts are very well suited to actually understand underlying rules, business rules, for example, and any other aspect that help us getting a clear terminology and anything that is relevant to the domain under consideration. And then many different potential stakeholders that are more related to the actual development and operation and maintenance of a software system. And at some point, we might also want to differentiate between different classes of systems. And embedded reactive systems, typically we have a bunch of stakeholders that come from a more hardware-dominated world, considering hardware, mechanics, mechatronics, electronics, and so on. In the case of business information systems, we might want to consider also stakeholders that have, for example, the sovereignty over a set of business processes, and so on. Now, there are a couple of more considerations to keep in mind when building up a stakeholder model. We have considerations that are more related to our abilities and how we should elicit their requirements, but also some considerations that are more related to the general project organization and project management. I will keep this short, but there are always some reflections on how we should involve the stakeholders in the decision-making process and the key reporting lines. In the maybe chain of command, there might be some hierarchies at an organization, at a client's or customer's organization that we must adhere to. If there's only one recommendation I would like to give you here, it is never take a shortcut. Never bypass key reporting lines, never jump the hierarchy. For example, if you are not really able to elicit requirements from a stakeholder, don't immediately approach their line managers, for example. As I mentioned a couple of times in the past lectures, requirements engineering is a lot about mediating. It's a lot about building trust. It's a lot about showing empathy. Once we bypass reporting lines, once we bypass hierarchies, chances are very high that we are stepping on someone's toe, leaving typically quite some crack in the trust relationship that is quite difficult to fix. Now, considerations that come to mind when it comes to the elicitation of requirements are quite manifold as well. One thing that you should always put some thoughts into is the relevance of the stakeholder for the project success, also for the reliability maybe of the requirements. Typically, we aim at finding what we call a champion. So when thinking about all the different potential stakeholders, a champion is always a great source for truly understanding the actual problem we intend to solve. A champion is not necessarily someone reflected in an organigram, might not be very high in the hierarchy. It could be, for example, an end user that is using the previously used system for 20 years and who knows very well what has worked well with this previous system that we might want to replace and what does not work at all and which problems we might want to fix. Another issue typically to be considered is the ability to commit to the project with resources and, more importantly, with time. This very much affects the availability of the stakeholders for the requirements elicitation workshops, for example. Also the ability to approve requirements. Always keep in mind a requirement without an explicit acceptance or approval is just an expensive assumption. Sometimes those with the most crazy requirements are not those to pay for the requirements. So this is just some food for thought. Finally, maybe the ability to express and formulate requirements also very much influences the way we want to represent the requirements or the notation we may want to use to specify our requirements. Now let's move on from stakeholders to stakeholder models. A stakeholder model is the representation of all relevant stakeholders, not all stakeholders, all relevant stakeholders and their relationships. What you can see here is just an example for the ATM, where we borrow from the UML notation to offer different associations, directed associations, but also generalization or inheritance that allows us to group the stakeholders according to different viewpoints. Which notation you use to express your stakeholder model doesn't care as much or matter as much as making clear what you mean with a notation. So whatever your notation you choose, make sure that you add a small legend to the specification. Now, why even bother with stakeholder models? Stakeholder models, as specified in our context specification, are typically a great foundation for many further content items. First and foremost, stakeholders are a great source for the elicitation of requirements, and stakeholders are those who express their goals that later then justify the requirements that serve as a rationale for the requirements. But even more, a subset of the stakeholders represents the end users, and those end users we will find in later content items, for example, in the form of actors as part of my use case models, as actors as part of my business process models, the scenarios I might want to model, and so on and so forth. Now, last thought I would like to share on the notion of stakeholders is the one on views and viewpoints. Now, as I said earlier, different stakeholders might have different views on the system. What we mean by that is that a view represents essentially the intention I follow with the system and the interest I have in the system. And I may very well group different stakeholders together to groups of stakeholders that have a same or similar view. For example, the end users all together follow the same perspective on a system, on how they intend to interact with this system. Why using views? Because views are a great means to structure also my elicitation workshops. Instead of interviewing, for example, all different end users individually, I might group them together into, for example, focus groups. Last but not least, personas are, I believe, a great way to understand the actual true human being behind these more abstract entities in a stakeholder model. Always remember, software is built by human beings for human beings, and it's very important to understand the true human nature behind these stakeholders, including things like what their goals are, what frustrations are, what their personalities are, what the technical skills are, their abilities are, fears, experiences with previously used systems, expectations, and so on and so forth. And what we do by elaborating these personas, we try to understand and capture typical characteristics for and this is important, fictional character. So with all due respect to all the Jill Andersons in this world, we refer here to a fictional character that is intended to represent one specific stakeholder, primarily the user group. Now, this is already everything I wanted to share with you on the general aspects of stakeholders. Let's move on now to the second topic, which is goals and goal models. Now, let's start. What are goals? Same as for stakeholders, stakeholder models that capture all relevant stakeholders and the relationships, a goal model captures all relevant goals and the relationships together. And a goal itself is a prescriptive statement of intent. That means that we describe an abstract and future comprehensive property that a system must fulfill with respect to its operational context and the process used to develop the system. So there are a couple of things buried in this definition, among them, and this is the most important one, prescriptive statement of intent. Now, important to understand is a goal is very different to a requirement. A requirement describes an abstract property that I still can measure, taking the perspective on the product. So a property of the product. A goal describes the explanation of this requirement, the underlying motivation. It's bound to a motivation, and it typically does not have any further rationale. A goal does not really need to be motivated. And the second thing that is important to understand is that we describe a future state of the system. What we tend to do with goals is to describe the intended to-be status in the future. So typically, requirements engineering is a lot about bringing change to a current situation where we might want to improve a current system and replace it with a new system. And goal models help us understanding what this to-be future status should be. So with this, we define a certain corridor in which we can still freely navigate. Think about the example, the system shall be secure. There are many ways to achieve this security, but this is what we describe typically with goal models. And lastly, it is very hard to determine when a goal is finally reached. This is very much true. To a certain extent, however, I believe that this is not really as much important as having a clear set of requirements that I can clearly test when accepting the software system and associating those requirements with the goals. But more about this in a second, what I mean exactly by this. Now, one thing to understand is also there are many, many different approaches to specify goals and goal models. And all these different approaches bring different classifications on how to classify goals. So we have one with AMDIRE, which I will show in a second. And I also don't want to go too much into detail when it comes to different classification goals, because they are historically grown and have a different purpose with their classification. But one typical example that you will find out there very often for a class of goals are quality-oriented goals. So one example for a quality-oriented goal is the one that we have discussed already. This is the new ATM shall be secure. Quality-oriented goals are a great means to infer quality requirements or non-functional requirements of a software system, and they are typically very easily expressed by the stakeholder. Another type of goal are optimization goals, often called also soft goals. These optimization goals are the ones that I mentioned when I said that we describe with goals typically future states of the new system. Here, just describe typically the margin in which I want to have certain improvements, like performance improvements, or here a more strategic example for a goal: the new railway system shall allow for a traffic increase, and where I can also add then some specific metrics and measurements, how I can then maybe assess to which extent this goal has been satisfied or not. Anti-goals are something quite interesting, because anti-goals define come from a more negative perspective, and they define more thresholds which I may not bypass. For example, the data loss is approximately 5% or less. The downtime is approximately 2% or less. These are typically anti-goals that you may find in one form or the other. But as I said at the beginning, the classification of the goals very much depends on the approach I choose. So don't restrict yourself too much to this predefined classification. Now let's keep talking about goals versus requirements. As I mentioned already, goals tend to be something more generic, comprehensive, rather abstract, bound to a motivation. In our worldview, goals are what describe the why questions. These are more context information. They explain why or why not certain requirements have which relevance or which priority. So in our example, the system shall be secure. This could be, of course, implemented or addressed with different requirements. We could ask the stakeholders, what do you mean by secure? Do you want us to store the ATM in the basement where nobody can access that system? Then it would be secure, strictly speaking, but of course not. What we do is we asking these why questions to address and to reflect more on the relevance of the actual requirements. And those requirements, this is the thing that we are interested in, because they describe measurable, testable, verifiable properties of the system that we want. And this is what addresses the what question, starting, for example, with the system shall prevent unauthorized access, which we then can further refine into specific requirements that are then of interest for us. So in scope is always the refinement of goals and the inference of requirements with the purpose of measurability, to making them measurable, which brings us to the notion of goal modeling and goal models. As I said earlier, a goal model captures all relevant goals. Also here, don't focus on capturing all possible goals, but only those that are really relevant for our project, as well as their dependencies. Now, regardless of the approach we might want to choose, there are at least two different classes of dependencies. One is the top-down dependencies given in a hierarchy or decomposition notion. This is the reason why we express goal models typically as taxonomies, as top-down refinements. And here, two relevant terms or relevant concepts for us is the goal refinement itself, the top-down. The idea is to refine goals to a level that allows us to infer our specific requirements. And this is what we mean by problem scoping. So by scoping, we refine goals until a point the system shall be secure, for example, that allows us to infer requirements. And we do so by asking typically what questions or how questions. What do you mean by secure? How do you want us to achieve this level of security? What is a sufficient or good enough security for you? Now, the other way around is also possible. This is what we mean by goal abstraction. Goal abstraction supports the explanation, justification, prioritization of requirements. What I mean by that? Very often you will have requirements that are measurable, testable, but they are not really explained or justified. They don't have a rationale. And this is what we can achieve by the why questions. If we have a requirement, or if you get a requirement in a workshop, for example, ask these why questions to express why is this requirement important, for you to understand how important the requirement is, and to link our requirements back with the goals and give them a proper rationale. Now, why even bothering with goal modeling? There's one thing that is quite important, and this brings us to the dependencies between the goals. So typically what we are interested in is understanding the relevance of the goals and how these are interrelated with each other. There are essentially two types of dependencies between goals. One is a more positive dependency. These are, with those I express that the achievement of one goal might have a positive influence on the achievement of the next, but the other dependency is actually more important for us because it's a conflict dependency. A conflict dependency means that achieving one goal tends to have a more negative influence on the other goal. Do you have an idea or an example for a typical conflict dependency at the level of goals?
Could it be that the system should be secure and have high availability, like easy access to it?
Exactly. This is exactly the example, exactly. So very often you have already clear warning signs. And with goal modeling, what we aim to do is identify conflicts as early as possible. Conflicts typically start at the level of the underlying goals. And whenever you hear things like security, but also usability, there's a lot of potential for conflicts. Another thing, I promised myself not to make any political jokes at this level. So typical candidates for potential conflicts are low development costs, low production costs, low operation costs, low maintenance costs, low costs. At the same time, high usability, high security, high availability. Or, as you suggested, much better between different quality issues, for example, security and usability. These tend to have a more conflict potential, at least. And as we learned in the first lecture, the earlier we detect potential defects and the earlier we detect potential conflicts, the better and the easier it is to resolve them. And who is responsible for resolving them? The man in the middle, the requirements engineer. And this brings me to one area, and I keep reflecting all the time how to phrase it ideally, but there is one major research area known under this larger umbrella of goal-oriented requirements engineering. And this brings me to a topic where I start having a little bit of a problem with complex goal models, at least when taken too far. Now, let me explain what I mean by that. So goal-oriented requirements engineering is like an umbrella term for many different approaches that are available in literature, covering approaches like chaos, ISTAR, Tropos. The list is very long. And the amount of scientific publications is much longer. We have thousands, and I mean it by that, thousands of publications dealing with goal-oriented requirements engineering. Now, what do these approaches propose? What they propose is to capture all goals and their relevant dependencies in a goal model. So far, so good. But at some point, and I'm still wondering when this happened, we started taking it a little bit too far, if I may say so, in the sense that these goal models propose to refine them, many of them at least propose to refine the goal models and the goals to a level where we don't even need requirements anymore, and even to play around with mathematical approaches and formalizations, allowing us to express the goals in logic-based expressions that capture a more formalized view on goals. and then allowing for things like automated, or I should say semi-automated simulations, semi-automated conflict identification, where I can just hit the button and I can get a tool-supported way of resolving those conflicts. Now, there's a lot of theoretical value, and they are very interesting from a theoretical perspective, no doubt at all. There's a lot of theoretical value to these goal models, but at the same time, I believe that to a certain extent, they might not be practical. So should one of these recordings ever get public, I cordially invite my colleagues from academia to challenge me on that. So far, we have empirical data from the AMDIRE initiative, among others, that very well suggest that these goal-oriented approaches are very well known in practice, but largely ignored. Now, it's not up to me to judge about the value of these or the practical value of these goal-oriented requirements engineering approaches like CHAOS, ISTAR, or TROPOS, but there's one good argument why we might not rely on them. So I want you to hear that they exist, but there is a good argument maybe not to use them. And it's the following one. Every model I create, and this is especially true for requirements engineering. Now, every model I create has one specific purpose, and it's communication. I use my models to structure information and to communicate between the engineers and the stakeholders. And I very much would allow myself to doubt that the typical stakeholders we are working with are able to really understand goal models if they are really complex and captured in more mathematical representations. So the essence is the following for us, for our worldview in this course. Goal models are very important because they allow us to identify conflicts, to identify the rationale of requirements, and to a certain extent we focus also on the establishment of goal models, but we focus in our approach on the very essentials. So what we do with AMDIRE is we concentrate on essentially 3 different classes of goals, which is business goals. Business goals tend to be more organization-specific strategic goals that have a more relevance on the project organization. I'm showing you some examples in the following. Usage goals. Usage goals are goals with a more relevance from the perspective of the end users and typically addressing more functional requirements. System goals typically addressing more non-functional, cross-cutting system properties. As I mentioned, AMDIRE focuses typically on, or I should say the AMDIRE concept model abstracts from methods and description techniques that have proven to be suitable to cover the needs in practice. And these are the typical 3 classes of goals that share typical viewpoints that stakeholders may have on a project or the product, and which is the reason why we capture those different classes of goals. Now, for the dependencies, also here we try to keep it simple and pragmatic. We focus on the decomposition that allows us to capture a goal and a taxonomy. A top-down view allows us to refine the goals and at a certain stage infer then, of course, requirements. And we have 2 types of interrelations. One is the supporting dependencies, where we say that one goal supports achieving another goal. For example, think of usability and safety in the healthcare sector. A system that is not usable is typically also not really safe to use. And the other one is conflict, where we say that achieving one goal might prevent achieving another goal. Usability and security is one such candidate. And of course, we have the rationale. With rationale, we mean that for every requirement we document, we might express one goal as a rationale answering the why question. Now, let's go back to the ATM example. At the ATM, I formulate here 3 different goals that you may, in one form or the other, also encounter in a practical example. Now, let's go through them and very quickly say which classes of goals these belong to. We distinguish, again, business goals that are rather strategic, usage goals that are rather functional, and system goals that are rather quality-oriented. So what do you think is the first one? Increase market share by 20%. Exactly. Exactly. It's an optimization goal, but taking a purely strategic perspective that justifies maybe the cost to a certain extent with taking a long-term perspective. Now, ensuring the integrity of data. Is it more usage or system? Exactly, system, exactly. Ensuring the integrity of data is a what would say quality-oriented goal. For us, it's a system goal that allows us to infer more detailed non-functional requirements. Sometimes we may classify them then later during the refinement of the requirements to functional requirements, but still the goal is a quality-oriented goal. The intention is to increase the quality. Allow users to withdraw money. Exactly. Allow users to withdraw money. Speaking, for example, in terms of agile, this could be a good starting point for a user story. And from there, I try to understand how users intend to interact with the software system to infer my functional requirements. So, and this is all I wanted to say on goal models. Again, same as for the stakeholder models. In the lab sessions, we will concentrate on establishing exemplary stakeholder models and goal models. Now let's conclude today's lecture on the topic of requirements elicitation. And one major focus I would like to put is to increase the awareness of where to begin. So let's cover this a little bit in a nutshell. So imagine that I guess that you can very well imagine that you are at the beginning of a project. Now there are a couple of prerequisites that characterize your current situation. One of them is that you have your, turn it around because these are reviews. One of them is that you have the AMDIRE model tailored. So a small warning on this: tailoring is only upfront is only possible to a certain extent because many things are not really clear at this stage. You don't know, for example, how your stakeholders are, what their abilities are to formulate requirements, to understand certain representations. You don't even know maybe how to set up the whole project and which of the content items are really relevant or not. So tailoring is always a continuous process that might accompany the first requirements elicitation workshops. But anyway, what we have is a basic idea of our AMDIRE model. And I have a set of templates created, for example, for the elicitation of requirements. Now, the AMDIRE model for now, let's put this aside. Okay, so we put this aside and start by the following. The first thing to do is to organize ourselves. So typically what we do is, and I've tried to provide you with a small, simplified, of course, step-by-step instruction, but the first things we do is to organize ourselves, think about what typical requirements sources might come to play. Stakeholders are one of potentially many different sources, and which requirements we might already have. So one of the typical characteristics of higher education courses and also training sessions in practice is that we somehow pretend that the world is about greenfield engineering, that we build a system on the green field with no surrounding systems, with no legacy application that we might want to replace. Of course, it's not like that. Typically, we want to improve a situation, we want to replace a system, and with those old systems, we might have already a couple of requirements. And those requirements give me already a good picture about the general direction of the project. Now, second step. What I do second is I identify the most relevant, not all of them, but the most relevant stakeholders, and I group them by their views. So one example could be to group the end users together by their views. Third step is I start with my requirements elicitation by applying, for example, creativity techniques, interview techniques, depending on the source, but let's focus for now on the stakeholders, for example, interviews or a focus group, which means that I go with them into a workshop and I start interviewing them. Fourth step, I start documenting my requirements. And here comes the trick. I start documenting my requirements, and what I don't do, I don't use my AMDIRE model or my document template and start writing everything where it belongs. This is not possible. This is not feasible. You cannot go to a workshop and start documenting together with them a use case model, for example. What I do instead, I use templates such as the Volare requirement specification template. Anything that is really easy to use, simple, even just a paper and a pen where I can take notes. And I document the most important things for now only. For example, a general description, maybe a rationale, maybe how this could be tested, and so on. Now, this is what we, or maybe on Post-its, this is what the agile way of working tends to be. Now, fifth step, and this is what separates this more agile, solution-oriented way from the engineering requirements engineering way. When I'm working following Scrum, having these post-its expressing some, user stories should be enough. What we do now is the following. We take all those notes and transfer them to models as far as we can using the AMDIRE content model. We take all the input we have and put it on AMDIRE. Some expressions might be very vague and could be more at the level of goals. The system shall be secure. It's a perfect candidate for a goal. Others might be very precise and measurable, could be atomic single functional requirements. Some could give an indicator on a use case. But at some point, we will see that there are some bits and pieces that might be missing. For example, I might just have a half-baked use case description. I might have a requirement that in itself alone is not enough. So I start speculating. I start filling all those gaps that might remain open. So once I have this big picture about all the single puzzle pieces, I start putting them together and filling up those gaps. And at this point is what I do is I make assumptions. Speculate as much as you can, but declare the requirements as assumptions. I complete the model as far as I can, and I go back to step 2, which is the major reason why requirements engineering should always be something iterative. I go back to step 2, start with my next workshops and approach them. Is this how we understood this correctly? Show them the outcomes, go with them through the requirement specifications and accept the requirements. Have them accept the requirements or change those requirements. And with every step, with every refinement, our idea becomes clearer and clearer. And this is also the way we concentrate on documenting the essence, the most relevant requirements. Many requirements might be clear to everyone. Those might not have to be documented. Focus on those things that remain unclear. This is the very idea, and this is really all there is to say for this general idea on how to get started using the AMDIRE approach, or more generally speaking, using an artifact-based approach to requirements engineering. Good. Then a couple of more thoughts on requirements sources and elicitation. So the list of potential sources is very long. Typically, we tend to think of stakeholders and their goals, and in fact, these are the primary sources we tend to rely on many or most of our projects. But there's much, much more to it. Documents, for example, regulatory documents, laws, standards, norms, legacy documents, including the specifications, the manuals, architectural descriptions of the previous systems that might have to be replaced, documentation of business processes, and so on and so forth, but also other systems. So typically we work either by replacing a legacy system or by developing a new system that might have some unique selling points in contrast to competitors. So we might do the analysis of the competitors. We might also maybe want to analyze systems that have a completely different purpose, but have still some similar or shared functions that we might want to reuse. For example, if I want to develop an app, I might want to reuse some pre-existing apps, like a navigation app that might want to reuse some maps, so we can study those maps coming from other systems. And there's much, much more to it. Quite recently, we started also working with usage data analysis, where we analyze how other systems, related systems, are used to focus and prioritize on those features that might be relevant from the end user perspective. App store mining, where we try to understand competitor systems, for example, just to give you one example, but also the analysis of discussion threads and social media. We find here things like sentiment analysis, that I can apply to understand, for example, this is what many companies do. Once they have released a new feature, I guess they don't read really what is written in the discussion threads, but they run a sentiment analysis to see, is the perception rather positive? Is it rather negative? Is it causing maybe anger? There are many, many ways to it, and the list is potentially endless. So, and same as the list for the requirement sources can be endless, so can be the list of potential elicitation techniques. We have many different techniques that are directed more at stakeholders, and we have many techniques that are more oriented and directed at the analysis of documents and data sets. So stakeholder-oriented techniques are, for example, question techniques, like interviews, questionnaires, focus groups, and so on. Observational techniques that we can use, for example, field observation or apprenticing. Apprenticing I did once for a week, where you just go, for example, to a customer's organization and work with the system that shall be replaced with a previously used legacy system, just to see and experience firsthand the actual flaws and where the difficulties are and what needs to be improved. There are many, many more creativity techniques now. Also in the era of design thinking and software engineering, we can use different creativity techniques and so on and so forth. Now, for you to take away, the list is very, very long. And I thought that instead of now introducing some bias and explaining you my favorite techniques that might potentially not be useful for you at all, what I have done is now created in the extended slide set a description of several techniques and a comparison of the different available techniques, so that you can look those techniques up that fit more your specific project needs. And so look them up, put some thoughts into them, and once you are at the point where you start planning your elicitation workshops, bring your ideas to the project Q&A sessions so that we can discuss them there. There is, however, one small last concluding tip I would like to give you, and this is based on a survey conducted by Samuel Fricker et al., who surveyed practitioners in different industry projects for the not only for the elicitation techniques that have been used, but those that have been successfully used. And among the many different results that they had, one I think is interesting for us, and is that most of the elicitation techniques focus on stakeholder workshops and on studying the existing systems and related documents. So this might be a good starting point for you. Now, just to conclude with a small outlook, what I would like you to do is put some thoughts into the most relevant sources that might be considered for your project, what the key stakeholders are, and focus on the key stakeholders, not on all of them, of course, and how you would like to approach them to elicit the requirements. So brainstorm, put some thoughts into it, let it sink in, and bring the ideas to the project Q&A sessions. Now, and with this, I would like to conclude today's lectures, and it's time for questions and discussion. Thank you very much. If not, thank you very much. Take care, everyone, and have a good day.